to a video lesson for week 8. I'm going to be going over a couple examples here, and this is from 5.4. If I could write a 4. 5.4, this is going to be question number, let's see, this is one we're going to do 3C. So this is on page 237. Okay, so what the question asks you is, we need to show that the following is a theorem. And the theorem is, and I'm just going to write it down here because we know that a theorem has to show up in the last line of a derivation. So we're going to have no starting premises, right? So no primary assumptions. And the theorem is A or, and then the second disjunct is a little bit bigger, and it might look really intimidating at first, but I assure you, although it looks intimidating at first sight, it's actually relatively easy to prove that this is in fact a theorem. So the disjunct is another disjunction, so this is not A or B, and we have on the inside a conjunction, not A or C. Ooh. This should be an or, C. Okay, so this might look, relatively intimidating. I mean, this seems like a really big sentence, but we're going to use the rules that we've been talking about, so the rules of inference and the rules of replacement for SD+. So it would be, it's really handy if you have your book with you right now on put on page 236, just so you can look at the rules that I'm going to be using here. Okay, so the idea is, as always, to keep working backwards. So we have this statement here, and this is a disjunction. And we want to work this into something that we think we can sort of pull out of thin air, effectively, right, using the rules of derivation. And one of the most common ways we've done that is we've always had to assume some kind of subderivation of some form or another. So a good strategy is to turn whatever theorem that you have, if it's not in the form of a conditional, to turn it into a conditional first so that we can do a big conditional proof. And the way we can do that is by using implication. So our last move here will be by implication. And implication says that you can swap back and forth between a conditional and a disjunction as long as you put the negation in the right spot when you go to the disjunction or from the disjunction. So in our case, this disjunction is equivalent to not A or and then the rest of this disjunct. And not A or C. A or C. And actually, now that I think about it, I think I might have actually skipped a step that I probably should have made, which is I can add 2 negations out in front of the A here. Oh, sorry, and this should be an implication. So this is now a material conditional right here. I probably should have actually put 2 negations out front here first as an intermediate step, and then gone from the disjunction to the to this material conditional. But I'm gonna just sort of skip that for now and ask that you make sure you keep that in mind when you actually go through these. And I'll make sure to do that again in class as well. So one of the habits that you'll probably form, is the one that I have, is I tend to just skip over the double negations. But we should, at least at the beginning, make sure that we actually go over these, including myself. So you should definitely try to hold me accountable to these as well. Okay, so now that we have this main conditional here, we can set up our usual conditional proof, right? We start with not A. And our goal at the bottom is going to be this consequence. Sorry. So here we're going to have not A or B, and not A or C. Okay, and this last, oh sorry, and I should do, this will be conditional introduction using the subderivation here. So we don't know what to cite yet. Okay, so this last line here in our subderivation is a conjunction. So we know at some point we have to get A or C, and at another point we have to get not A or B. And then we can use conjunction introduction using these two lines. And by now, this should hopefully seem really easy to you, right? Because we already have not A. And remember, we can use disjunction introduction to introduce anything else we like that we already have, either as assumption that's available to us or something that we've derived. So since we already have not A, I can just introduce not B by disjunction introduction. And similarly here, I can do disjunction introduction citing line. If we make this line 1, these will be line 1. Okay. In the interest of time, I'm not going to fill in the rest of these because I want to go over a couple other examples, but you should make sure to go back and fill in these justifications. So let's work on another one. We'll switch colors here, and this time we'll do 4C. Okay, and 4C asks us to prove an equivalence. So what we need to do when we're proving an equivalence is we need to do two derivations. In the first case, we assume the first sentence as our primary assumption, and our goal is to derive the second sentence. And then in the second derivation, we do exactly the opposite. So 4C starts with the one sentence A and B, then C, and our goal here is not A, then C, then not B. So we're showing that this sentence is equivalent to this sentence by, in the first case, assuming this sentence and then deriving this as our goal. And then in our second derivation, we're going to do exactly the opposite. So we're going to assume this sentence here, and our goal in this case is going to derive A and B, then C. Okay, so let's start with this one here. So what we need to do is we can try to work, from the top down and from the bottom up to try to get a point where they meet using the rules of the replacement. So one of the first things I notice is that the order of the appearance of the atomic letters are different in the beginning than they are at the end. So at some point we know we're going to have to use commutation to flip some of these. The other thing I notice too is that there's a conjunction that holds between A and B. And then the main connective is a conditional. So we can play around a little bit, and there's going to be a variety of different ways you can work this out. But one of the things I like to do right away is to just start breaking, in this case, since I'm not proving a theorem, I have another premise to work with. I'm not going to make use of this conditional by setting up a subderivation. You could do that, but I'm going to go a different route and try to use just the rules of replacement and the rules of inference without having to do any kind of subderivations. So the first thing I notice is that I can actually use implication to turn this conditional into a disjunction. So how do I do that? Well, I end up having not A, then C, or not B. And if you look at implication, you'll notice that this is a valid inference. This is a valid application of it. And notice this time I actually made sure to put up the not out in front. So one of the first things I can do is actually just to get rid of these this double negation and write A then C or not B. And the way I will have gotten from here to here is by doing the double negation. Here I would have introduced it, but when I'm kind of working backwards, I'm kind of getting rid of it. So I'm just making that move explicit now. So we definitely should make sure to keep that in mind when we're doing these derivations. Okay, so now I've got a disjunction as my main connective, and one of the things I need to do is, I need to rearrange these atomic letters so that I get the A and the B beside each other. And before I do that, I'm going to also get rid of this conditional here. So I'm going to turn the conditional in here into not A or C, or not B. And this is again by implication. Oh, that should be down here. So I'm just writing them below just because I'm kind of working backwards. So moving from this step to this step, we'll be using implication. And if you have a look at that rule, you'll see that's in fact the case. Okay, so now what I can do is I can use association to move some of these parentheses around. So one of the things I can do now is, actually before I do that, change my mind last second. What I'm going to do is I'm going to use, oh, that was the wrong one, commutation, to shift around this B over to this side. So I can do this. I can go not B or not A or C. Okay, so this will have been by commutation. And the reason why I want to do this is because I want to move these parentheses to encapsulate A or B. So I want to be able to write not B or not A or C. And this will be by association. Oh, man, I keep writing it up there. Erase that cuss word for a bit. Okay. And now that I have A and B, at least side by side here, now I can use commutation again to reverse them. So I can go not A or not B or C. This will be by commutation. Notice also that I don't actually have to worry about what the main connective is when I'm using these rules of replacement. Because, as the name suggests, I'm replacing syntactic parts of the sentences, and I'm allowed to do that. So I don't have to actually worry that the main connective is has the same form or not. That's okay. I can sort of just look inside a set of parentheses and do the rules of replacement just there. I don't have to worry about the whole sentence having that particular form. So that's another reason why the rules of SD plus are a lot more powerful than the regular SD, powerful in the sense that they provide us a faster way of doing proofs, but they won't let us do any more proofs. Okay, so now that I have this disjunction, I'm almost there, right? I need to make this main connective, I need to turn this into a conditional, and then I also need to have a conjunction out here. Well, if you use De Morgan's law, then I can actually take this negation out and change the connective from a disjunction to a conjunction. Right, so this will have been by De Morgan's law, and then it's actually just one more step from the starting assumption. Namely, if we use commutation, then we can turn this disjunct, right, so the negation of the left disjunct and the right disjunct, you can turn that into a conjunction by the replacement rule of commutation. And then we're done, and I have to fill out the numbers here for the steps, but I won't do that here. But you should definitely make sure that you do this when you do your proofs. But what I wanted to show you was a strategy that I was sort of using. So I was reasoning backwards a little bit and trying to get the forms to fit in the right way. So now we have to actually prove the other direction. And at first you might, think, oh man, like this is going to be kind of tough. What I need to do in in this case is again use this conditional, then set up a conditional proof, assume A and B, try to get C in the same way that we did in the system SD. But actually, one of the nice things again about the rules of SD Plus is because these rules of replacement apply just to syntactic forms, so that we don't have to worry about the main connective or the whole sentence. We can actually do these operations on just parts of the sentences. You won't actually have to do anything else other than do this backwards. So you'll notice that in this time, although we worked backwards, we could have also thought about this as working forwards. So I could have gone from this sentence, I could have just started working downwards right away using the strategy I've been doing here to go back up. In other words, you'll notice that I can move from this sentence to not. If A, then C, then not B. Moving from here to here is by double negation, which adds this extra, these two extra negations out in front. Oh, I'm sorry. That's implication. Oh, almost screwed that up. This is implication, not double negation. Sorry. In the next step, I'm going to get rid of double negation. I'm going to go if A then C, then not B. And this is by double negation. And hopefully you'll see that I'm actually just starting to mirror the moves I'm making backwards, just doing them right here. So if you've solved for one, it'll be very easy to solve for the other. But you still need to show that you can actually do this, because the ordering will be a little bit different in terms of the justifications that you use. But the idea will be basically the same. So we'll notice back here, we turned, oh sorry, sorry guys, this is a disjunction. Hopefully you caught that. And this is a disjunction as well, right? Because I used implication to turn this conditional into a disjunction. So this is a disjunction here as well. And then what I did over here, I moved and turned this conditional into a disjunction. So I went not A or C or not B. And that I did by commutation. Okay, so I'll stop there, but you see the idea, right? I mean, once you get the one direction, it'll be very easy to get the other direction just by working exactly in the direction that you were before.